This is my second take of this project, but I think this one's a really good one, and I'm really excited about this. This is a locked box, and in order to open this box, you have to get the correct combination of these buttons all at once. So I'll make a little demonstration. So let's say we press this button. This is obviously not the right whole combination. So I press this button, it doesn't open, and if I press this button, it doesn't open. But if I press all of these buttons at the same time, you can see it opens. And so if I bring my fingers off, then it closes again. So you can see inside of there I've stored some stuff in there. So yeah. Now on the computer today, I'm trying something new. I split the code into different parts and all. I hope that makes it easier to understand. It's in 4 parts. See you there. In the first part of this project, we set up variables. First, we'll include a library, and we'll include the servo library, because that's what we'll be using to open and close the box. Next, we'll set up some pin variables to keep track of all of the pins we're going to be using. So we'll make a variable S pins for switch pins, but these will be push buttons just because that's what I had at the time of making this project. So we're going to be using pins 4, 5, 6, and 7. And then we're just going to be declaring the servo pin, which will be 9, because that's one of the few pins on the Arduino that allows for pulse width modulation. Now we'll initialize the servo motor variable, and we'll make 2 variables that are important for the lock mechanism of this to work. So first we're going to make an array called it's the positions, and it's going to default as them all being off. And then the goal position, if you want to open it, is going to be another array. And this can be anything you want. This is for you to customize. I'm just going to set it to what I had in the example. And that should be all for the variables at the top. So the next part is going to be setup. So we'll make a function. It's a good idea to set up everything with functions instead of putting all of them inside of the setup function. So inside setup pins, we'll attach the servo motor to pin 9, or the servo pin. And then we'll set it into a default position. Now this default position might be different for your servo motor, just because it's whatever is in the position you want it to be in when you're going to have the box be closed. That's what you want your default to be. And now we can set up a for loop with the pin modes in it. So we'll be looping through 4 because we have 4 different buttons. Okay, so now that we have that for loop, we can just go pin mode X pin, and that will be pin I, and that will be an input for this situation. And just because this makes more sense to have this plural, I'm going to make that plural. Then the setup function, we can call setup pins. And now we're on to the next section. Now this one's a little bit more complicated. It's more of something that you will understand as you go and as you do more. But the entire purpose of this is to make a function that will just compare 2 arrays. So we'll be taking in 4 parameters. This is the first array of the 2. This is array B. And then this is the length of array A. And then, this is the length of array A and the length of array B. Okay, now that we have all of those, we'll make a variable called n, and we'll check first. Just we know that if these 2 arrays aren't the same length, then they're not going to be equal. So we'll just check for that. If the length of array 1 is not the length of array, B, A and B, then we can return false. But in this case, that won't work because they're going to be the same length anyway. Now, you can make a 1-line for loop here. So we'll use n and set that to 0. And then after that, we'll check if that's less than the length of array A. Then we'll iterate through to the next loop, and then we can check inside of that if this value in array A, if value n of array A is not equal to value n of array B, or index n of array B, then we'll return false. And if none of those things are, if there's no condition that makes it false, then we'll just return true. That was probably the densest and most complicated part, and now we're on to the final part, which is the fun and the logic, of course. So first we're going to check for all the positions of the switches. So of course we'll make another for loop using I, and we'll be iterating through 4 of them once again. Okay. Now inside of this, we'll make a variable called status, and we'll set that equal to digital read, and we'll be reading this index I of the buttons, and we'll check if status is high. So basically if the button is on. Then we can update the positions that we've entered for all these switches, and we'll update this one to 1. So that means that it's on. We could use high and low, but I'd rather not make an array of booleans, so I've chosen to do it this way. Now we can check if status is low, then we'll just set this to 0, and that should be the default. And finally, this is what's important, is we have to check if they actually got the code right. So we can write if array, and we'll compare these 2 arrays, and there'll be position and goal position, and of course they're both 4 in length. Then, so if that's true, we don't have to write equals true. It just understands that if this is true, then it'll just run because it'll return true up there. Then we can write to the servo motor, however, whatever degrees you want to open the box. So for me, it's 95 degrees. And then otherwise, we can just write to the servo, because we want it to close if it's incorrect. So otherwise we'll just tell it to go back to its default position. So congratulations, you just finished it. Now you can see that we have this working, and when I press the buttons in the correct way, the box opens.